domain is the set of positive integers. The function values a1, a2, a3, a4, and an are the terms of the sequence. And then if the domain of the function consists of the first n positive integers only, then the sequence is a finite sequence. So just some vocab. Like you're not going to be tested on vocab, but these things pop up. Infinite sequence means it doesn't have an end. So an example of an infinite sequence could be all the even numbers. All the even numbers would be 2, 4, 6, 8, and it would never end, okay? That's your infinite sequence. It has some sort of a pattern. The function values are called the terms of the sequence. So if I were to refer to 2, 4, 6, 8, ... then A1 is 2, A2 is 4, A3 is 6, A4 is 8, and then any term in that sequence is that AN notation. The last thing says if it consists of just a number of positive integers or positive, then the sequence is finite. So if I just said 2, 4, 6, 8, and that ... wasn't on the end, now it's a finite sequence. Okay, so infinite doesn't end, continues on in that pattern. Finite obviously ends. I did right. Directions say write the first 4 terms of the sequence, and it says assume n begins with 1. So the first one we plug in is A1. So A1 would be 2, and then we plug in 1 in the place of the n. So this would be 2 minus 4, which is negative 2. And then I would do A2, and A2 is 2 times 2 minus 4, 4 minus 4, which is 0. And then I go A3, which is 2 times 3 minus 4, 6 minus 4, which is 2. And then I go A4, 2 times 4 minus 4, which is 8 minus 4, which is 4. So when we write these answers, you will list them in order you got them. Negative 2, 0, 2, and 4. Those would be the first 4 terms in this sequence.
Is that finite or
Say again.
is that finite or just
That would be finite. So if it says first 4, it would be finite. Yeah. All right, you do B. Or 2 over 2, which is 1. That's the first term. 2 times 2 over 2 plus 1 is 4 over 3. That's the second term. 2 times 3 over 3 plus 1 is 6 over 4, which is 3 over 2. And then fourth term, 2 times 4 over 4 plus 1, 8 over 5. So our terms are 1 4/3, 3 halves, and 8/5. Good on those? Okay. This would say write the first, I'm just going to do 3. We understand what we're doing. If I said 5, yes, like we would just keep going. But for time purposes, we're going to make them smaller just so we don't have to keep plugging in. If it said write the first 3 terms of the sequence, then I'm going to do A1, I'm going to do A2, and I'm going to do A3. So negative 1 to the first times 1 over 1 plus 1. And then I'm going to do negative 1 to the second times 2 over 2 plus 1. And then I'm going to do negative 1 to the third times 3 over 3 plus 1. So this would be negative 1 times 1/2 or negative 1/2. This would be positive 1 times 2/3, which is 2/3. And this would be negative 1 times 3/4, which is negative 3/4. I don't know. I really don't. I don't know what happened. I know. I don't know if I hit something weird, but it should be a PDF. It should just convert it. Good on just a generic sequence. Yes? We're just plugging in. Okay. Correct. All right. Now, it could give you a term or it could give you an equation for a series, and it could ask for any specific term within the series. So if it tells you this whole thing is AN, but it wants A4, all you have to do is plug in 4. So I would get 4 squared over 2 times 4 plus 1, which is 16 over 8 plus 1, or 16/9. One term. Typically, you'll get like maybe, and you'll see we're going to get into arithmetic and geometric, and so it will be different. But there's not going to be a bunch of questions that ask you for like 5 terms. It would be stupid. You'd be there all day. Okay. Okay, I think I took this one out of your slides, right? You don't see this one? No. Okay, that was my intent. All right, recursive sequences are next. So a recursive sequence is one that relies on the value of the previous term, okay? So it it is take the previous and do something to it to get this one. Then do the same thing to this one to get the next one. So for example, a recursive could be the even numbers, because if I take 2 and I add 2 to it, I get 4. I add 2 to it, I get 6. So you're always basing it on the previous one. If it wants terms in a recursive sequence, it's going to give you a starting point. It's going to give you A1 or A2 or something. It gives you a starting point. So the notation to me is the weirdest, but it is very easy if you understand what it says. This is what it looks like. It literally looks like k plus 1. So this first one, let's say it's 1. This is k plus 1 equals A, the bottom being k, plus 10. And all this means is take the previous number and add 10 to it, for example. So if my first term is 5, then the second term would be 5 plus 10, which is 15. And then the next term would be 15 plus 10, which is 25. And then the next term would be 25 plus 10, which is 35. So in these, you're not just plugging in. You're building up to it, if it makes sense. Those are called recursive. So in that case, you'll see something like this. And again, we're going to change this to 4. Just make it smaller. Write the first 4. I crossed out first and not 5. First is fine. First 4 terms of the sequence defined recursively. My first term, 15. My second term would be 15 plus 3, 18. A3 would be 18 plus 3, 21. And A4 would be 21 plus 3, 24. So you're just taking the previous one. In this case, it's saying add 3.
So you just don't pay attention to the k plus 1.
K plus 1 means the one after k is equal to k plus 3. That's all it is. So the notation looks weird, but it's all saying is the next term is this term plus 3. Yep. We're going to skip this one, which I think you have skipped. All right, so the little exclamation mark that you were like, is that supposed to be there? Yes, it's supposed to be here. Okay, this is called a factorial. And it's not like 7 factorial or 5 factorial is not just an excited 5. It's like 5. No, it means take 5 and multiply it by 1 less than, 1 less than, 1 less until you get to 1. So if it says 5 factorial, this is 5 times 4 times 3 times 2 times 1. If it said 7 factorial, it's 7 times 6 times 5 times 4 times 3 times 2 times 1. Your calculators do have a factorial button on them. They have an exclamation mark. It is on, I think it's in your, okay, it is under math, the math button. Then you go over to PROB for probability, and the third thing in the line is your exclamation. Fourth thing in the line is your exclamation mark. So if I wanted to do 7 factorial, I could do 7 times 6 times 5 times 4 times 3 times 2. I wouldn't waste the time on doing the 1. Or I could type in there 7 exclamation mark, which is, again, math, probability, 4. And this is 5,040. You go math, PROB, prob, 4. And that's the exclamation mark. You got to put 7 first. So if you want to go back and hit insert, yeah, you got to do 7 first. All right, so the other thing that's weird and you don't always know, you don't see, unless you have a calculator, your calculator will tell you this, but if you don't have it, you have to know that 0 factorial is actually 1, okay? So any term counts down to 1 and 0 itself is just 1. So how are these going to get built in? You'll see something like this. Find the first, again, we're going to change this to 3 because I think after that point you get to it. The first 3 terms of the sequence. So A1 is 1 over 1 plus 1 factorial, which becomes 1 over 2 factorial. And 2 factorial would be 2 times 1, which is 2. And then I go A2. A2 would be 1 over 2 plus 1 factorial, which is 1 over 3 factorial, which is 1 over 3 times 2 times 1, or 1/6. And then we'll do one more. A3, 1 over 3 plus 1 factorial, which is 1 over 4 factorial, 1 over 4 times 3 times 2 times 1, 1 over 24. And we would list them 1/2, 1/6, 1/24. Right?
Yeah, Mark, it was fun. Thanks for that comment. Thanks for that comment.
Questions so far?
Oh, you're right. Wait, don't say.
Okay. Okay, no, these are still not bad. No, it's still not bad. All right, so these, again, they look like they're going to be bad, and you would not have a calculator on these, so just a heads up, you can't just type in 5 factorial over 7 factorial. But there is a trick to it, okay? So don't do what I'm about to do, because this is why you would waste your time. This is 5 times 4 times 3 times 2 times 1 over 7 times 6 times 5 times 4 times 3 times 2 times 1. And then I would cancel the 1s, I would cancel through the 2s, I would cancel through the 3s, I would cancel through the 4s, I would cancel through the 5s, right? And I get 1 over 42. And that is one way to do it. But if you learn this trick, it saves you work, which we love to do. Take the bigger factorial and break it down until you hit the smaller factorial. So what's bigger, 5 or 7? 7. So I'm going to, oh boy, I'm going to leave 5 alone. I'm going to take the 7, and I'm going to make it 7 times 6 times, I'm going to stop at the 5 factorial. And then the 5 factorials cancel, and it's 1 over 42. So if you have a factorial in the top and the bottom, it doesn't matter what's what, whichever one's bigger, you're going to break down until you get to the smaller one, and then you eliminate the smaller ones. Does that make sense? Yes? Okay, now go to B. I don't know these values, but what's going to be bigger, n plus 2 or n? N plus 2. So I'm going to take n plus 2 and I'm going to break it down until it hits n. So the first one is n plus 2, right? What comes after n plus 2? What's one smaller? N plus 1. What's 1 smaller than n plus 1? N, and I've hit my n factorial. And they cancel out. And then you could literally leave it as n plus 2 times n plus 1, or you could FOIL it out, n squared plus 3n plus 2. Both. It'll take both. Yep. Still good. Standardized tests like factorials, because it's one of those things that you can do quick if you know what you're doing, and if you don't, you waste your time. I feel like standardized tests love those things. All right, now we're going to talk about summation notation. These are your sigmas, okay? They actually are a math term, not a stupid term to describe other people, okay? A sigma, which is that little e, means summation, okay? This is also good college prep because that is in like half of your fraternity and sorority names, okay? That symbol says find the sum of all the terms in this sequence, beginning with the one at the bottom and ending at the one on the top. We start at the one on the bottom, we stop at the one on the top. So if this just said 2n, for example, there's 2 ways to do this. And if there was, let's say this said 3, we'll make it small, okay? There's 2 ways to do this. One is you would start at the bottom, plug in 1. So 2 times 1 is 2. Then plug in 2. 2 times 2 is 4. Then plug in 3. 2 times 3 is 6. And then stop because I hit the 3 at the top. So I start at the one on the bottom. I go to the one at the top. And then I add these up. And it's 12. So we start at the term at the bottom. We plug it in. We started at 1. And we stop at the one at the top, which means we plug in 1, we plug in 2, we plug in 3. And then I add all those numbers together. That's what summation notation means. There are also tricks I'm going to teach you in a minute that simplify this stuff. But that in its form is the basics of it. What sucks is if it's like 1 on the bottom and 100 at the top, right? That you want to know the other tricks for. Yeah. I don't want to plug in 1 to 100. Yeah. All right, so start with this one. What's at the bottom? Yours does not look like this because it's messed up. Take a picture.
Look at it.
I don't understand it. 0. Where are we starting? 0. Where are we stopping? 3. I have to plug in 0. I have to plug in 1. I have to plug in 2. I have to plug in 3. So 0 is 0 plus 1 times 0 minus 2. 1 times negative 2, which is negative 2. 1 is 1 plus 1 times 1 minus 2. 2 times negative 1, negative 2. 2 would be 2 plus 1. 2 minus 2. 3 times 0, which is 0. And 3. 3 plus 1. times 3 minus 2, 4 times 1, which is 4. And then we add them all together. Negative 2 and negative 2 is negative 4, plus 0 stays the same, plus 4. And I actually get 0. You could, the sigma is what tells you what to do. So a sum can be 0, a sum can be negative, a sum can be a fraction, a sum can be a decimal. There's no rule on what a sum has to look like, okay? But again, important that we note, we start at the bottom, we stop at the number at the top. We still good? Okay, so these, oh, this is what, all right, these are your summation rules, okay? And the good news is I will give you these on a test, okay? I don't think you get them in calc, but that's Miss Ferrier's problem, not mine. So these are shortcuts. Some of them look more complicated than a shortcut would be, but and they are. So sometimes it's just as easy to plug stuff in. But when there is a large range of plugging numbers in, it is definitely easier to use these shortcuts. So for example, if we're at that 1 to 100 range, it's way easier to use these. Now, what do you notice about every single one of these bottom? They all start at 1. You cannot use these rules the same way if they start at 0. You have to plug in. Does that make sense? So all of them have to start at 1. This means, and I'm going to kind of interpret each one of them. This first one means that the only thing next to that sigma is a constant. So it could be something like I equals 1, 4, and let's say this is 2. Now, if you did it without this shortcut, there's nothing to plug in, which means term 1 is 2, term 2 is 2, term 3 is 2, term 4 is also 2. And then you would add them all up, okay? With this shortcut, all you do is take the number on the top and multiply it times the number on the right, and my summation is 8. So again, not so bad if it's 1 to 4, but if that said 1 to 27, you don't want to have to add up 27 twos. It's way easier to do 27 times 2. Second one is just a variable. So if this looked like 4i equals 1, let's say it said n. Then I'm going to take, actually it would say I, sorry, the variable would match. This would say I. This variable and this variable will match. They can change, but they will match. So for this one, we do n times n plus 1 over 2. Our n is the number at the top. So it would be 4 times 4 plus 1 over 2. 4 times 5 over 2, which is 10. Which would be the same if I plugged in 1, plugged in 2, plugged in 3, plugged in 4, and added them all together. But the bigger that number on the top, the more time that takes. Okay, next one is a variable squared. So if this said sigma I equals 1, and let's say again 4 at the top, and this said I squared. That pattern is n times n plus 1 times 2n plus 1 over 6. So I would do 4 times 4 plus 1 times 2 times 4 plus 1 over 6. And I would get 4 times 5 times 9 over 6. I would simplify, make my life easier, and I get 30. Still with me?
Even without a calculator, this is so much easier than this.
I mean, not if that number at the top is 20.
20 is not that big.
You're going to plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then add them all together. Yeah, not advisable. Yeah. All right, now we get to cubed, and I would say cubed is as high as we go. Okay, if it said, same thing, 4 on top, I equals 1, and this said I cubed. It is n squared times n plus 1 squared over 4. So this would be 4 squared times 4 plus 1 squared over 4. And this is 16 times 5 squared over 4. 16 times 25 over 4. 4 goes into 16 4 times, and this is 100. Way faster than doing 1 cubed, 2 cubed, 3 cubed, 4 cubed, and then adding them together. Well, not way faster, but faster. Okay? And again, I wouldn't really worry about the things on the bottom. So number 5 basically says, and we're going to do this in the next one. Well, actually, I'll go through them. But I wouldn't worry about using these. I think it's easier to understand it when you expand it. These are how we expand things. So if this says there is a sum here, then I can actually take that sum and I can break it apart, okay? So if it said sum I equals 1, 4, and it said 2I plus, well, let's just do I plus 3 first. I plus 3. Daniel, stay with us. Then I can break this apart into I equals 1 of 4I plus I equals 1 for 3. Now I can follow my summation rule of just a single variable by doing that second one, and I can follow the constant by doing the first one. So for this one I would use n times n plus 1 over 2 where n is 4, and then I will add to it 3 times 4. So you break them apart, okay? We'll do this again on the next example, and then the very last one says if there's a number multiplying by your term, you can just bring it to the front and then follow your summation rules and then multiply it at the end. So for example, if it said I equals 1, 2I, and again, let's say this is 4. For this rule to work, it has to be just I. So I would take the 2, bump it to the front. It's going to be 2 times the summation of I from 1 to 4. And then I use my rule from I. So it's 2 times n times n plus 1 over 2, where n is 4. So I'd get 2 times 4 times 5 over 2, or 2 times 10, which is 20. So every sum and difference can get broken up into its individual terms, and then anything that has a coefficient on it, that coefficient can get bumped to the front. Yeah. Where? This part? Yeah. No worries. All right, so tell me one way to do A.
Put 2 in the front.
Good. So bump the 2 to the front. 2, the summation of I equals 1 to 4 times I. The 2 is going to stay there. The I is this second rule. 2 times n plus 1 over 2. And my n is 4, right? 4. It's not always 4. I gave it 4 in these examples, but it's not always 4. So 2 times 4 times 5 over 2. 2 goes into 4 twice. 2 times 10. This is the exact same one I just made up on the fly on the other one. Yep. Okay. What's another way to do it if you don't know your summation rules? Plug in 1, plug in 2, plug in 3, plug in 4, and add them together. Yes? That one's not as bad. Like, I feel like this is not that big of a deal to use a shortcut on. Okay, now go to B. I'm going to break these apart. So this is going to be I equals 1 of 4, I squared, plus I equals 1 for 3. So the squared is 1 here. That is your n times n plus 1 times 2n minus 1 over 6. And in this case, my n is 4. So this is 4 times 4 plus 1 times 2 times 4 plus 1 all over 6. And then I'm going to add to that 4 times 3. So I get 4 times 5 times 8 plus 1, which is 9, over 6 plus 12. 2, 3, 3 goes into 9. 30 plus 12, which is 42. Remember, the n is what's at top if the bottom is 1. If it's not, we count the terms, but that's different. You don't have to worry about that yet. Yeah.
We're going to have the summations on the test.
Yes, I will give you the summation box on the test. Yeah. Questions? Okay. I'm teaching you how to do this so you can check answers. Obviously, if there is questions on the homework that requires summation, you are not using a calculator. You need to show the work. So on your math menu, you have to scroll all the way to the bottom, or you could go up and start your way back down on the bottom. Summation is 0. If you hit 0, it brings up the little box. It doesn't matter what variable you put in the bottom. So I'm going to put the variable as x because that's what my button does. X equals, nope, ignore me. I'm in polar from AP. Ignore that. I was in polar. It wasn't you. Okay. You had x. Okay. So if I'm going to do that last example, we started at 1. At the top, we went to 4. And on the right, it would be x squared plus 3. X squared plus, nope, I can't see my own writing. Plus 3. And you should get the answer. So whatever's next to it, you type next to it. The I on the bottom, you go x, but all of your i's become x's. That's the only difference. Easy stuff, yes? Okay.